Okay, so looking at section 1.4, just so you guys are aware, remember the test is on Friday. That means the notebook check is also going to be Friday. I'm also going to collect your homework, your weekly homework. I'm not going to wait till Monday. 1, we don't have school Monday. 2, I want it done before the test. So I'm collecting that all test day. Section 1.4 is a new line in the table of contents. It is a brand new section, new page numbers and everything. Section 1.4 is called Limits to and at Infinity. So go ahead and take a second and pause the video and update your table of contents. While you're doing that, make sure that you are coloring the corners of your pages. Remember, I need each chapter to be one color so that I can flip to each chapter later in the year when I'm working on notebook checks. So hopefully you've updated your table of contents, starting with section 1.4. So the first thing that we're going to talk about is limits at infinity. So limits at infinity, or you could also call it an infinite limit, is a limit that increases or decreases without bound. So those are where our answers are going to be infinity or negative infinity. Sorry about my handwriting on the tablet. Or decreases without bound. And note, there's something very important about infinite limits, okay? If you have the limit as x approaches c of your function, and you get either positive infinity or negative infinity as your answer, then keep in mind that this does not mean that the limit exists. Yes, we got an answer, but remember, a limit exists if they meet. So this does not mean that the limit exists. This is very important. But it says how the limit fails to exist. So it just describes that D&E. So you want to be careful about this because sometimes if you get infinity as an answer, multiple choice might not have infinity. Your answer is going to be D, does not exist in that case. Infinity is just more specific. So just be careful with that. That just because you got an answer as infinity doesn't mean the limit exists because it isn't meeting up, okay? So we have already looked at these a little bit. We've done infinite limits graphically. So we've said, okay, what about these limits? And here's the graph. So first we have the limit as x approaches 3 to the positive side. So that means the right of 1 over x minus 3. And this is the graph of 1 over x minus 3, by the way. And we have the limit as x approaches 3 from the left of this function. So this green dotted line is 3. And when we follow our function on the right, it keeps going up with no indication of stopping. So that's when we get our answer of infinity. And when we look at the left, it keeps going down. So that's when we get an answer of negative infinity. Okay, so we've looked at that with graphs. We have also looked at infinite limits without a graph. So what's happened so far is we've been given an equation like this. I do want you to write these down in this section because I want you to have this information all together. We've done limits, so this is the limit as x approaches -2 from the left of 1 over x plus 2 squared. And what we've done without a graph so far is we've made a table. So we've had x values and y values. And if we want on the left, that means smaller. So if we use 2 here, then to get smaller values, or -2, excuse me, to get smaller values, so to be more negative, if we had $2 and we took away another cent, you'd be in debt a total of -$2.01. And then -2.02, and negative 2.03. So take a second, pause the video, plug these numbers in and see if you can get an answer. Okay, hopefully you have calculated those. For this one, we get 1,111.1, and then we get 2,500, and then we get 10,000. When we plug in -2, that does give us undefined because that's a 0 on the bottom. So we know when we were looking at these problems, we said, oh, look, that's going to get bigger. There is no small pattern that we can follow. So our answer with a table here, in this case, is also positive infinity. Okay. So a graph probably would have been doing the same thing as this graph did. It would go up forever without end. So what's new today is we want to talk about when we don't have either of these. So, sorry about that, just got to pull out the time. Looking at this first one, we have the limit as x approaches 0 from the right and the limit as x approaches 0 from the left. So you can do two things. You can make a table or make a graph. I would suggest that 1 over x is one of those, like we know x squared is a parabola. You should know what the graph of 1 over x looks like. It's a rational function. So it looks like this. It has two pieces, and if it was negative 1 over x, then the two pieces would be in the other corners. Okay, it would just flip. But it's positive, so this is our function. And so when we're looking at 0, we're looking right here. And when we look to the right, that's going to be positive infinity. And when we look to the left, that's going to be negative infinity. There really is no other way to find the answer to these graphs than being able to graph it on your own. This is a graph that they would expect you to know on the non-calculator portion of the exam, so just keep that in mind. This example, if we look at this example, we can use some of our information from above because we have two parts to this example. We have the limit as x approaches 0 from the right, and then we have 3 plus 1 over x. Well, this is technically two different limits. We can write this as the limit as x approaches 0 from the right of 3 plus the limit as x approaches 0 from the right of 1 over x. Well, using our information from above, or that same graph, we know that the limit as x approaches 0 from the right of 1 over x is infinity. So this is going to be plus infinity. The limit of anything of just a number is going to be just a number. And then let's think about it for a second. If we have 3 plus infinity, that little 3 is not really going to have a huge impact on this huge infinity idea. So that number is just going to stay infinity. It'll just be 3 ahead of the other infinity. Okay, so that doesn't really impact it. The infinity takes over and it becomes infinity anyways. So all of this can combine to give us some general rules when we're working with infinity. So we have properties of infinite limits. This means that when we're working with infinity, there are some things that we can use again and again, so we can kind of shorten when we're thinking about our problems. So our properties of infinite limits have to do with if we have a limit that's infinity and a limit that's just a number. So if we have the limit as x approaches c, so these are general rules, remember we don't have a specific number right now, of f of x, and that's equal to infinity, and let's say that we have another limit as x approaches c of g of x, and this one is equal to capital L, okay? Capital L means some number, okay? It could be 2, it could be 32, we don't know. If it's a number, so just like that other problem where we had 3 plus infinity, so maybe L is 3, and that's what we're going to be talking about. Our first one, we have 3 properties. One, if we have the limit as x approaches c of f of x plus or minus g of x. And we're taking this limit, so that means that our limit of f of x is infinity, and our limit of g of x is L. So we're going to either add or subtract L. Well, that really doesn't impact. There's no way that L is going to be big enough, even if it's 1,000. Infinity is still this huge idea. So that's not really going to impact your answer. So that's going to go ahead and be infinity. So anytime you have a finite number and you add or subtract it to infinity, that's just going to be infinity anyways. Our second one is the limit as x approaches c if you multiply. So we have f of x times g of x. This can be two things, okay? Because we can have infinity times a positive L, or we can have infinity times a negative L. That just changes the sign. So multiplying it won't change it from infinity. These just tell us if it's going to be positive infinity or negative infinity. So if we have positive infinity times a positive L, we'll get positive infinity. If we have positive infinity times a negative L, that does change it to negative infinity. The infinity stays, but the sign changes. And then our last one, if we have the limit as x approaches c, and we have g of x divided by f of x. So this means that we have g of x is the L, and f of x is the infinity when we take the limit. This is going to be 0 every time. If infinity is on the bottom, your answer will be 0. Because think about that. The bottom of a denominator, the bottom of a fraction tells you how many pieces you're making. So if that gets really, really, really big, think about a pizza. If you make 2 pieces of pizza, like take a whole pizza, cut it in 2 pieces, you each get a half. That's huge. But the bigger, the more you cut the pizza, the more amount of slices you make, those slices are going to get smaller and smaller and smaller. And if we cut enough pieces from one pizza to like share with everybody at the school, that would be insane. We wouldn't get a slice of pizza at all because it'd be basically nothing. Nothing is 0. Okay, that's how that works. Something very important to keep in mind right here. If you ever have a number over infinity, you get 0. If you have infinity over a number, you're going to get plus or minus infinity, depending on the sign of that number. Okay, so infinity stays if it's on the top, but if it's on the bottom, it's making that fraction really, really small. And the smallest we can get is 0. Okay, similar rules apply for negative infinity. So you would just repeat everything with negative infinity, but it's all the same. Okay. The last thing is we have indeterminate forms. So if you see any of these things, infinity over infinity, infinity minus infinity, 0 over 0, 0 times infinity, 0 to the 0, 1 to the infinity, infinity to the 0, these are indeterminate. And we cannot use them. So if you get that answer, you have to do something else. It did not work. You did not get an accurate answer. Whether that's factoring, or we'll go over a couple different things in the next video, you're going to have to go over and redo the problem because plugging in did not work. You have to do something else. So make sure that you know and have written down all of these indeterminate forms.